Hi everyone, it's Coach Fred here, and today I'm going to be going over translations of functions, whether that be left, right, or up, down. So we're going to start by, it says graph this function on Desmos, sketch the graph of f of x in red and on the axis and fill in the table of values. Okay, so I'm actually going to do the table of values first. We've looked at the function, this absolute value function, and if I were to plot some tables of values, I'd probably put in -2, -1, 0, 1, and 2. And if we input them for x, our outputs, or our f of x or y, would give me 2, 1, 0, 1, and 2. All right, so if I was to plot those points, I'd get -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And at this point, you know that that's a nice absolute value graph. It looks like a V, something like that. All right, I am going to go to Desmos, as it indicated, and I have here the absolute value graph. That's the one we just did, that we just plotted. It looks beautiful. And the question is, what happens when I take the absolute value of x, and then I add 2 to it? So in your mind, you might see what happened really, really clearly, okay? So this graph just moved up 2 units. Okay, so I'm going to switch to green. Nothing else changed about it, though. Okay, all right, so let's think about what values changed. 0, 0 remained the same. What happened at the x of 1? At x of 1, I now have an x of 3. I have a y of 3. Let me put it here. All right. At an x of 2, I now have a y of 4. And if I go to the other side, I'm going to see that same thing. You can see clearly that each of the points were shifted, each of the y values were shifted up 2. All right, so looking at the function, this is like f of x equals the absolute value, but it is moved up 2 units. Hopefully you're seeing what you notice about the x and the y values is the x's remained the same, but the y's changed by 2. Okay, and that should kind of start to make sense to you because the function, the thing we're doing to the x, is the absolute value. And then we do it, and then we just add 2 to it. All right, let's try this one. I'd love you to make a guess as to what you think is going to happen. Okay, so I'm going to, again, plot my points. I'll do it in red. So -2, -1, 0, 1, 2. We know these points. We're going to need to know these points. I'm going to plot my points. I get my absolute value graph. It's a nice V, just like that. So what do you think is happening here? It's like f of x, but moved. All right, hopefully you're saying up 3 units. So I wonder what's going to change. Hopefully you're saying, well, the x's should remain the same, but each of these points, 1, 2, 3, each of the y's should move up 3 units. And that is exactly what's happening to the graph. So it would be -2, -1, 0, 1, and 2, and then 5, 4, 3, 4. When this was 2, 2, so this would be 2, 5. Okay, so we can describe and graph these using something I like to refer to as a point-by-point translation. It's kind of like a rule that you're going to apply to the parent graph. So remember, we call this the parent function. So this parent function is the absolute value of x. So if any point x, y is on the graph of the parent, then the point-by-point translation would be the x's remain the same, but the y's you're going to add 3 to. And that is the point-by-point translation. I'm going to refer to it as a rule. So that means I can take any point on the absolute value function. All I'm going to do to the y's is add 3. I'm going to keep the x's. I'm going to change the y's by 3. All right, well, what about the quadratic function? Well, we've worked with this function, and we know that we've plugged in, again, -2, -1, 0, 1, and 2. But this time, the output, meaning the function, is squaring those numbers. So we would get 4, 1, 0, 1, and 4. You should really be picturing that graph easily. Here we go, 2, 1, 2, 3, 4, and then 4 over here. This doesn't look like a V. This one looks more like a U, something like that. All right, so this is the function. So what are we doing to the function? It looks like x squared, but let's look on Desmos to see what it does. So now I have x squared, my parent. Let me delete this. So there's my parent, beautiful. So x squared minus 5. Huh, what happened? It just shifted down 5 units. Okay, so it's like x squared, but it's moved down 5. All right, so if I want to describe the point-by-point translation, it's taking all of these points and just moving them down 5 units. Or 1, 2, that's only 4 units. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And I'll switch to blue. And so it's looking something like that. Something like that. So again, the x's remain the same. And the y's are going to go down by 5. And there's my point. So if I want to describe the translation, graph it by using a point-to-point translation, then all you're going to do, the x's remain the same, and the y's are going to be, you're going to subtract 5 from all the y's. So x, y minus 5. Okay, so this tells me a little bit about moving graphs up and down. We're going to look in our next video at what happens when we shift them left and right. Have a great day.